Welcome to our Vector Forum 24 and to the fifth instantiation. I'm glad to be today here together with Frances Paulisch of Siemens Healthineers. We will in a moment also introduce herself. The Vector Forum is giving you a summary on a variety of technical topics, and this time we look into architecture. My name is Christoph Ebert, and I will briefly give the word to Frances, or you can just say a few words about yourself and then I will continue.
Okay. Hi, welcome everybody to this session. My name is Frances Paulisch. I'm the head of the Global Software Initiative at Siemens Healthineers. So we drive various central strategic software topics at our company.
Thanks, Frances. And our global topic this year is deploying emerging technologies. And so
Christoph, we can't hear you.
We have started the Vector Forum on the different deployment aspects for technologies. Briefly, who we are. Vector, about 4,000 people. And we have different branches. We are market leader in embedded software for cars, in test equipment, and also have different other activities. My responsibility is in consulting worldwide. And the forum addresses four major themes on which we work. We have the alliteration with the T, trust, technology, transformation, training, and we try to balance the different focus areas over these four topics. And as you can see, emerging technologies, that's in a way covering most of these four topics. Obviously, technology, trust, because it's also about robustness, resilience, cybersecurity, because most is about connectivity. Transformation, because deploying means that there is a change, and the change is typically not something people are eager to do. And training, because it's part of the transition that you really understand what is the benefit and how to use these technologies. And I'm specifically glad that we have today presentation because it nicely connects also these four topics, especially also the training aspect, which in the previous four themes was not so much used. Few things on this Vector Forum, how we run operationally. We are now in the intro, which takes maximum of 10 minutes. Then we have this presentation of Frances Paulisch. We have Q&A. That is really relevant because that allows you to directly interact with Frances Paulisch, ask questions, ask anything on technical topics on what she presented. And then we will have a 5-minute closing, which allows that we finish within the 60 minutes. For those of you who listen remote in a way that you're not online at the live session, you will obviously not have the chance to ask the questions directly with this forum, but you can certainly connect to us with email. From a technical perspective, the experience shows the Microsoft Teams application is better than the browser. And we also know that Teams, especially the new Teams, is certainly not error-free. You might have realized that I was muted without reason somewhere in the beginning. This happens quite frequently, such technical glitches. It's a complex software, and that means if it gets too bad, we will switch into WebEx. Have a look to your mail so that in case that we change the platform, you will get a mail with a URL how to connect with WebEx. Interaction is by means of chat window. So you see that on the right side of your screen in Teams, and you can just ask questions during the presentation. You can also rate existing questions. And I will later on select the questions according to clustering some topics and also looking to the rating so that those with the most votes will have a higher probability to being addressed. Finally, we also run a quiz in each of these Vector Forum, and the link is here. And you will also get a QR afterwards and can win some trainings that fits to the topic. You can also win books and stuff, so it's worth doing it. And you might be annoyed with seeing all these symbols, but I just think it's important because, as we say, those risks which you mitigate will not actively hunt you afterwards. So have a look how you could escape in the worst case wherever you are in the world. We take the full hour, and you will afterwards get a recording. Also, we will hand out some more material. That could take a while, but we certainly will do that. And check your connectivity. Typically, this is the major risk in any of these webinars. And the chat window was mentioned. And of course, the timing needs also a good cup of coffee or tea, because we are somewhere after lunch here in Europe. We are in breakfast time in US, and we are somewhere after dinner or dinner time in Asia. None is really perfect in terms of being highly motivated. The talk will certainly motivate you. I know Francis for a while, and beyond that, help yourself with sufficient supplies, whatever you need. Getting more to the topic, we make typically a survey which we run on an annual basis, asking our clients in terms of what would be major challenges, and we see short and midterm is competence. And that is why we also want to talk about competence today, because competence gaps immediately impact your competitiveness. It impacts the innovation, that's obvious, but it impacts also quality, also a topic of today. And that means extra work, rework, extra cost, and certainly a lot of effort which you could better invest on other things. The program shows different topics, and we have today software architecture at Siemens Healthineers with Francis Paulisch, and we run that further on 2 more sessions in next week and the week after. And we will also have these recordings in our YouTube channel. Now for this 5th instantiation on software architecture, the question is always, how can we balance a short-term project pressure with long-term product needs? And that's of course a kind of undecidable question, because I mean, if you don't have the short-term cash flow, you don't have to worry about the long-term product suitability. On the other side, if you have that short-term cash flow and you don't invest it wisely, your product will sooner or later also have severe problems. And for that reason, have a check into how you can really improve both on the side of competencies, but also on the side of the software you're creating. And that starts with architecture, with design, because once you're on the code, it's hard to repair things. Good software starts with good architecture. And we have here a small survey, which you should see on your chat window, which is about software competencies. It tells we systematically grow our software competencies. It's a yes/no question, and you could just give an answer on this, and we collect the answers and we show the results afterwards. All that being said, I think we have reached our 10-minute mark, and now I'm really glad to hand over to Francis and also to learn about the initiatives at Siemens Healthineers. Francis, floor is to you.
Okay. Okay, thanks so much, Christoph, for the great introduction. I have a fifth T for you, the T in your 4 T's, also the tea to drink. So maybe the next slide you can have a 5th one as well.
That's a good one.
I'm very glad to be here with you today on the topic of software architecture at Siemens Healthineers. So thank you very much for the invitation. So maybe one slide background about Siemens Healthineers. So we are a large medical technology company. We are, of course, related to Siemens, but we have our own business in this healthcare sector that includes things like diagnostic imaging, but also lab diagnostics, cancer care, and a broad span of medical technologies. These are shown in the middle here in this triangle, are sort of 3 main pushes of the company regarding the personalization topic in the patient twinning. And also the precision therapy is about intelligent and image-guided treatments. And at the bottom, you can see as the foundation for everything is leveraging digital and software basically, and data and AI. And so we have this mix, as I think many of you have, from I guess Jan Bosch likes to say, from atoms to bits, right? We're a company with a lot more physical products, but getting more and more into the software area. And from the numbers you can see here, I didn't include it in the slide, but we have over 5,000 software engineers at Siemens Healthineers and spread around the world. We're, of course, a very global company. And so I think it's important to focus on, and you'll see this maybe as a common theme throughout the presentation today, what brings us together? What do we have as commonalities? Christoph mentioned we know each other a while, so maybe that's a good commonality, that we all know Christoph Ebert. But between many of the domains, right, the vector is quite active, I know, in automotive space, but not only, right? So I think there is more common between our types of businesses than different, I think. So I think there's a lot of commonalities. We're in the automotive, transportation, energy. Many of us have products that are cyber physical systems, so a mix of hardware and software. We've got a strong focus on things like safety and cybersecurity. Probably also, like us, you probably have some kind of regulatory requirements. And for all of these things, we need to also have attention to what we call the quality attributes, sometimes called non-functional requirements. So not just the features, what exactly does the product do, but also things, does it scale? Does it have good performance? Is it reliable? And so there are these first aspects that are mentioned here are called operational attributes. And also there's another category, that's why I put them on a separate line, like maintainability. These are developmental attributes. So it's a different part, right? And one is on the product itself, and the one is about, is the code readable? Is it maintainable? Is it extensible, right? That's different category than, does it respond quickly enough within X milliseconds? And also there's new trends like observability coming along. So we all have, I think, probably high and growing complexity, fast pace of change. That's why you're in events like this, trying to find out what's the next things that are coming, what do I need to be aware of. You probably also have a global R&D footprint, as we do, and a growing focus on digitalization and software. So we're in this increasingly volatile, uncertain, complex, and ambiguous world. I'm sure many of you have heard of this abbreviation VUCA. We're having faster innovation cycles, and the world is not as predictable as it was. And maybe not only in the product world, but overall in our social lives, right? Things used to change at a much slower pace, the Industrial Revolution and so on, and things are getting, faster and faster all the time. And that makes the importance of having, fast feedback. And maybe also regarding training, it's just not feasible to know it all, right? You can't just go to university, learn how to become a mechanical engineer, and you can do that the rest of your life. You have to keep up with the changes, and you have to want to keep up with the change, right? The only thing that's constant is change. And so we have to have good ways of dealing with this change, because this change is coming very fast. Software is a major driver of it. All of the easy things have been done. We have more and more systems that are more and more interconnected, right? And that makes it also challenging to predict, how does this combination of systems work, right? And so we have lots of, imagine all these cogwheels all moving at, different paces of change. And some of those cogwheels are moving slowly, others are moving fast. And we need to be able to manage that whole conglomeration, right? And then things like new trends coming in, like what's the impact of artificial intelligence on all of this? Will that make that easier or harder. I think the jury's maybe still out on that, but also has a big impact on how we also can use artificial intelligence in an appropriate way to maybe have a better grip on some of these topics, and also see what it can bring in the future, and what things one needs to be aware of when using it. So architecture is a very important part of all of this, and it's the key foundation for many of these cross-cutting concerns that we have. And it's relevant to the quality attributes, but also it's the core of the communication, and it enables us to continuously evolve these systems, especially because we're in this VUCA world. We can't be having a new product come out every year that's completely different. We have to have a base version of the product that is planned from the beginning to be able to change and adapt in certain ways, right? In maybe different countries or in different situations, take advantage of the commonalities. Again, what are the commonalities and what are the differences between these new versions, right? And it's an architectural way of thinking to be able to do that in a cost-effective way. Think early about what it is that's going to change in your system and what's going to be stable, and do the architecture of your system in that way. I have a quote here in the box from meanwhile a little bit older State of the DevOps report about some of the reasons why architecture is helpful here. And maybe I'll go into maybe the first point about being able to segregate our systems in certain ways, right? If we can focus on having the more critical parts of our system in one area of the product and the non-critical parts or less critical parts in a different one, then we can focus our attention, focus the effort more on the ones that are maybe more critical, right? So we have to see how we can address segregation, how we can adapt the pace of change. There's a quote here from Brian Foote and Joseph Yoder about trying to structure your system so that things that will change often are in the same part of the system, right? If you have some, I don't know, fast changing user interface part, and you're having a new, I don't know, mobile interface to your product, and it is tightly coupled with the core basis of your product, then you have to do all of the approval and all of the validation of your whole product every time you change some bit on the user interface. So think about it early on, what's going to change fast and what's going to change medium fast and what's going to change slow, and structure your product in that way, or take that into consideration in your architecture. I talked a lot about the architecture, but the architects, my main focus, or what we have found is very, very beneficial, is to focus on the architects and make sure that they have everything they need in their toolbox, in their portfolio, in their knowledge, as much as possible, because they are, in German you'd say, the Spinne im Netz, right? They are sort of the central person that is dealing with all of these other stakeholders and roles, right? They're talking to the head of R&D, they're talking to business, they're talking to testing, and they need to understand those roles. They need to be able to speak the language of their counterpart. And their counterpart has to be able to understand the software architect. If the business responsible person comes in and wants to know from the software architect if this product is going to be customizable for this, that, and the other, and they start coming along in Angular and Kafka and various technical terms, the business responsible will not understand them. It's important. The communication is essential, and the software architect needs to be able to speak the language of the stakeholder and also be understood and be able to explain in a appropriate way the relevant information for the various stakeholders. And they need to do that in a whole broad range of to stakeholders. And so they need lots more competencies than just software architecture. They are good software architects. They are good developers typically also, they have a lot of software expertise, but that's only part of their knowledge and their expertise. They need a whole portfolio of other knowledge as well. And they're sort of living, I like to think of them as living bridges. This picture on the left shows a bridge that is made in a place in India, I believe, where the roots go across this stream to the other side. And that's really, it's a living bridge. And the architect is sort of a symbol also of such a living bridge. And this architect is involved in many different areas. So not just in architecture, as I mentioned, but also having to do with the business and strategy. You can see on the left the organizational context. In the middle, in the orange part, you can see they're also involved in the requirements, in the tool selection, in the testing strategies. These complex systems have to be built in such a way that they are also very testable. So you have to have a test architecture and a test strategy on how to do this. And the architect has to talk to and be able to communicate very, very well and align very well with the test strategy topics, so that we can be sure in an efficient way that this can be done appropriately. So when we focus on software architecture, we also have a strong focus on software culture. And maybe that's, our company has more of a hardware history, I guess. So I think many of you maybe are in the same boat, so to speak, of trying to bring a software culture into organizations that are maybe more in the slower pace of change and maybe are more focused on the hardware, right? The whole business models are set up that way, right? We need perhaps even different business models for selling software-based products than we do other kinds of hardware-based, mainly hardware products. And so we need to have the appropriate culture and understanding in the company as well. And so that's also one of the things that we find is very important and focus on. And this idea of what's common and what's variable fits in many different situations. I mean, I've spoken of it here in the introduction, in our first slide about, us coming together as in the commonalities in our products. But you'll see also in some of the later slides, we apply this same concept also to our training portfolio. So there's parts of our architect training portfolio that are common and other parts that are variable. And that helps that we have a common way of communication. Many of the social skills trainings, parts of the training that we do, those are common across the program. And when we go deep into the bits, into the software architect program, it's of course different than when we are in the system architect program or in the test architect program. Another main thing is that we need to make sure that the architects know how to address trade-offs, and that they do those trade-offs. They can take everything into account. They consider that holistically. They need to take not only the technical aspects, but also the business aspects. Does this fit to the organization? What are the social implications, that they balance this, right? Because all of the time, one of the main things that the architects have to do is sort of to decide which way to go and what are the trade-offs. And we give them tools on how to go about doing that and what to think about. And we teach them how to think about problem solving. It's not so much bits and bytes, but it's really learning how to handle certain situations and then to resolve them in a way that it will have a long-lived, that is long-living approach. And overall, not just with the architects, but also with all of our software engineering personnel, we need a culture of professionalism and collaboration, a willingness and just a drive and a pull to continuously want to learn, and to also have a failure culture where we don't say, oh, that was wrong, right? It's really the best learning is when we have failed and have tried something in a small scale, right? Ideally, you don't want to fail big, you want to fail fast and small and learn from that. It's incredible learning opportunities. And so you need to have established that culture at your company. And I'm very glad at our company that we do have a big push towards agile and this kind of very modern culture. So I think that it's a really great topic to be able to address at a company. But I think not all companies are that way. I'm in the lucky case that at Siemens Healthineers, we do have quite a modern culture. So I included here several quotes in the slides, and so this one from Mary and Tom Poppendieck about, think big, but act small, fail fast, and learn rapidly, right? You need to learn from your mistakes quickly. You need to have this big vision, but you have to also be hands-on, right? You don't want architects that are just up in the clouds, so to say, that are that are thinking only very abstractly. They really should be, professional software experts themselves and really know also the bits and bytes, right? And so they need to be able to do that. And with the moving on to the training aspect and not just the architects, we apply this also to the company-wide learning program that we have established, right? So we also have a big plan when we started this project back at Siemens in, 2006, 2007. We had a big plan, but we said we are going to act small. We're going to start on the very first role, our senior software architect, because that is the one which has the most impact. Those are the architects of our upcoming next generation, most important cross-cutting topics. And so this was also a quote that I would say we applied when we were coming up with a training program, not a training program, that sounds too pushy to say training program, a learning program. It's a pull, right? The person should be learning from us, right? And this was also a clear way when we established this topic. So we established the so-called software curriculum. It's a set of architecture-based learning programs, originally at Siemens, and we now also continue it at Siemens Healthineers. So across the company, we have as much commonality. Again, the common thread through our topic is this commonality topic. It's very common as much as it can be between the companies, but in some cases there are specialities at Siemens versus Healthineers. But back when we started together, the goal was to really establish this common standard and ensure that it also had business understanding and leadership and social skills in there, because at the time, we analyzed projects that had not gone well, and they were not failing due to technical reasons. They were failing due to, miscommunication issues or misunderstandings, or somebody maybe wanting to be maybe more important than the other, so they didn't want to give up their persons to be working in a different team. But you see also outside, some major things, right? Where I think some rocket went up and somebody was measuring in inches and somebody else was measuring in centimeters, right? And then the thing crashed, right? It's not typically technical things. It's really communication is the root of many of these problems. And so when we're starting this program, it was very, very important to the top management who gave us backing for investing in this program. It's expensive activity to create such a topic, right? We looked a lot outside at, are there other things that we could use? And we found lots and lots of technical training, but we didn't have one that had the kind of scope and addressing the kind of systems, the complex cyber-physical systems that we have, addresses the social skills in a way that we thought that we needed. So we ended up saying we'll have to grow our own, and we're big enough to grow our own, but we like to share our insights because I think maybe parts of this can also be relevant in your companies. We also explicitly had this networking aspect, and that's one of the things that the software initiative drives a lot. We actually have a cross-company software architecture board that discusses cross-company topics, right? It would be totally silly for us if different business lines, totally independent of each other, made various technical decisions or decisions that had maybe technical impact. We also have a common peer review process. So a business line can say, I would like a senior software architect in a different business line to have a look at what we're doing. And we can offer that kind of thing. So a lot of networking topics are bringing in external experts also to have a meeting with them. So like Gregor Hopi we've had, or Keblin Henny, right? We bring various experts in for various networking topics as well. And basically encouraging also this failure culture. And it was agreed to be set up, driven by the software initiative, to have this role-based specific training be the basis of it, but also to bring immediate benefit, right? This, as I mentioned, was a pretty big investment back then from Siemens AG, and they wanted to get their benefit out of it. And so it was decided that, which was really a super idea and really paid off in the end, that the persons should really have an appropriate project when they enter the program, and they need to apply the learnings in the very project that they're responsible for. So immediately during the course of the 9-month or so training, they immediately get benefit because they're already applying improved techniques and topics on their current super important complex project. And we agreed to also have a certification. That was also a lot of discussion on the certification topic, because there are some other external certifications out there that are typically sort of more multiple choice based or so on, and we really wanted a very, very intense certification. So we ask questions on the knowledge, but also on the experience. How did you apply TDD in this project and so on, right? And really have them be interviewed by other experienced peers on these topics, and also testing the social skills and putting the persons in particular situations. How would you react here and there, and so on. And initially we had this program, as mentioned, for the senior software architects, but then we also expanded that over the years to the software architects. Those are architects of not quite such complex projects, a little bit smaller category projects, and also expanded to system architects. Even though it's called software curriculum, it's still, we also have a training program explicitly on, cyber physical systems, and we really get into the mechatronics and the electronics, and at a particular level. Don't get down so much in the equivalent of the bits and bytes there, but we do address explicitly, the different needs of the system architects, getting more into the, the late phases and other activities. Is the project recyclable and sustainable and things like that, and also the test architects, because this is a common thread also throughout all of our programs. And then we have, for this program, we set up a set of guiding principles. You'll be glad to know I won't go through all these. You read them as homework, but I'd like to focus on the 5 topics in the middle, because these are the 5 focus areas. These are topics that are common, again, to all of our 4 architect programs. And I think I alluded at the beginning that we don't teach the architects so much about architecting, but also on the other topics. So just to give you a feel, in the senior software architect program, there's about 40% of the time is spent on the architecture topic, and about 20% on social skills, and 15% on business understanding, and then the rest appropriately spread out. But you can see these persons are already highly skilled architects when they come in, and we sort of do the special polishing at the end, making sure that they know everything they need to know about all of the other things that are important for them to know in order to have successful, long-living projects. So this is showing sort of the life cycle of the senior software architect program. It's sort of the most complex of them all. We have a very high entry bar to get into the program. You need a letter from the R&D manager, and you need to show that you have, various competencies. And so this is also, I think, one of the secrets of success is that we have this very high entry bar, and they're already very, very skilled software architects when they come into the program. And so we address the other topics as well, but when they come out, they're not going to be worse than they were when they came in, right? They're already very high quality architects when they come into the program, and then they get more expanded and get a more common company-wide understanding on what all is important in the area of architecture. And throughout these, they have various gates to go through where they have various questions that they need to answer and do knowledge gates where they need to respond to various questions. And at the end, also, there is a certification interview by various assessors. These are typically software R&D heads or other highly experienced senior software architects. And so it's sort of a by the peers that know this topic very well. And there's not that many in all of these. So throughout Siemens Healthineers, we have, I guess, 250 overall in all of these areas. But so senior software architects, I think between 40 and 50 of our 5,000 software engineers. So how did we go about doing this? Well, we wanted to improve the performance of our software projects. So we interviewed many people. This was back in the old days, back when we were together with Siemens, did it this way. We had these experts and stakeholders that we interviewed, and we had a very systematic approach where we described the role. You can see here in this spider diagram the 5 topics that I mentioned earlier: business understanding, architecture, requirements, testing, and social. And within each of these, what is exactly the experience that a senior software architect or a software architect needs to know? And do they need to know that as a basic understanding so that they just know about it? Or do they need to be able to apply it? So then that would be advanced category. Or do they need to be expert in it, where they drive and coach and can help improve others? And so the senior software architects have to be in that category for architecture, but also in the governance and guidance. They have to be able to drive others and mentor the younger software architects and lead the way. And then we transform this into training programs, and we have their expert teachers. And this was another maybe secret of success. We have expert teachers who are actual senior software architects or are actually in these various roles, and they are highly skilled at their own normal day job, so to speak, and in the training of this. And this is really extremely important and a real success factor, right? If having an external person, we do have some external persons that are also trained, but they know the system very well and are also expert architects. But this is very successful because it really is highly motivating to the participant that they can talk to their teacher who is actually a peer and really knows in depth what they're talking about. And then we have also the networking topic, and the participant really pulls this knowledge, this learning from various online sources. And then there's also the virtual instructor-led training and the in-person training. So we try to increasingly push typically more technical things out into the, go and learn it yourself. Make sure you're up to speed on the latest technical topic XYZ, so that we can really use the quality time when we really are together in a Teams meeting or in person at a hotel, and can talk in depth about typically more the social or cultural topics or exchange of real experiences between the persons. And this networking topic is also very important so that they can easily get a second opinion on various topics on how to do things. And that really encourages indirectly that we have a more common approach across the company. So it's not by mandate, but sort of by bottom up, more agreement on a common approach. And this is a slide just showing how we apply this commonality variability analysis also to the training assets, right? We have reusable assets of concept boards or some slides. We don't have that many slides. We're more online and have more discussions and interactive training to enable the learning of the participants. But we try to consider what can be core across the set of programs and what is specific for a system architect or a test architect. So this was all about the architect program, and I would also like to spend one slide or a short time on the software craftsmanship topic, because I focus very much on the architecture programs. And we also, for the software engineers, the developers, we also are very, very convinced on the benefits of software craftsmanship. So software craftsmanship, you can think of it like in the old days in Europe, you'd have your, your shoemaker who was an expert shoemaker, right? And they were originally an apprentice and then became, a journeyman and then became a master themselves. Imagine that same constellation for software developer, right? They have some guidance from the expert. In our case, often like Kevlin Henney is our sort of software craftsmanship expert, or some other internal colleagues. But they see in real how this can really work, and they apply clean code. So clean code is one of our favorite books in this space by Robert C. Martin, Uncle Bob Martin, and he encourages very easy to understand, easy to maintain code. Some very basic principles like you ain't going to need it, right? Don't fill up your product with all kinds of special effects that you don't know yet if you're going to need them, right? Build this up gradually. Don't repeat yourself. Being able to have prioritize readability over conciseness. So don't try to write the code in just one line of code because that's somehow more efficient, but write it in a way that somebody can understand it, right? People are going to read code 10 times more than they're going to write it. I think there's a quote, I should have included it here, but there's a quote about, writing code for a computer to understand is easy compared to writing code so that a colleague or yourself 6 months later is able to read and understand it, right? We need to have maintainable systems. We, like you, have systems that are out in the field easy 10 years, right? And we need to be able to maintain them. And so if they're not written well, if they're not written in a way that we can understand and test them, that's not good, right? So we focus very much on this software craftsmanship, and it's this expertise on how to write and how to be able to write in a way that's well readable and well maintainable. But it's also, again, like with the architecture, it's a cultural topic. As mentioned here in this quote from Sandro Mancuso, it's a mindset where the developers are responsible for their code. They want to provide their code in an elegant way that others can understand and say, oh, that's a nice piece of code. That's a nice way of solving that issue. And this technical excellence, there's a lot of trends towards agile, right? And I mentioned also we have a lot of tendency towards agile development. It's a very important topic, but also this topic is connected to the Agile Manifesto. Maybe you're not so aware. There's the Agile Manifesto, but there's also a set of principles behind the Agile Manifesto. And one of those principles is about this technical excellence. It says continuous attention to technical excellence and good design enhances agility. So also the original Agile Manifesto folks were very keen on having this kind of technical excellence. And maybe even less known to you, I hope I can give you some learnings for the day. There is actually also a software craftsmanship manifesto that basically takes some of those 4 points from the Agile manifesto and it sort of adds on to them, not just, you have to have a look at it, but there is a growing community. It's also very active, also active in Germany and in maybe Europe, maybe more so than America, but it is a very active and growing community. It's becoming modern again to focus on software craftsmanship in our view. And so we need to make sure that we're, like I said earlier, we need to make sure that we've got high quality code and not just focus on the features, but having low technical debt, having maintainable code, readable code. Because, in contrast to systems where you cannot make things so complex, right? If you've got all these wires and cables and physical things, there's a limit from physics how complex you could make your system, right? Software is not subject to the law of physics, right? We could make theoretically, we don't, thank goodness, but theoretically you could make software so complex, there's no physical limits to it. So we have to control ourselves, right? And have well-written code and motivate the software engineers to work in this way and to be responsible, have the right culture, not let code that is not well maintained go on to the next phase in the life cycle. So we've established also this training on software craftsmanship with hands-on coding exercises. Again, the key, having expert trainers. There is some you can learn on your own, but it really helps to have the expert. So coming to the close, invest in architecture. It is so easy to show that the investment you make in architecture pays off, right? If you have one problem in your products, I'm sure you can find a way of saying, if we had had a good architect, we would have avoided that, right? So architecture, it is expensive to invest in that. You need to invest in handling your technical debt, but this investment definitely pays off. Here's another quote from Brian Foote and Joseph Yoder. If you think good architecture is expensive, try bad architecture, right? This is the topic in our view to really focus on because there's such a central role. Make sure you have hands-on project related things. You don't want to have a frontal slideshow of somebody just going through a bunch of slides like I did, but rather, hands-on, showing in person how to do this, because these attendees and the participants, they need to also be able to actually do it in practice and be able to also convey that to their peers, right? And keep a strong focus on these operational and developmental qualities and not only features. So those are the things like performance and scalability and availability, as well as things like maintainability, readability, and so on. And structure the systems to reduce the dependencies, try to adjust according to the pace of change. Don't have your user interface closely coupled to the core of your product, for example, right? And explicitly focus on the culture and the teamwork and the motivation, right? The people in software engineering space, there's such a huge span of expertise and impact, productivity per person, right? The way we can best address that is to have the right culture and the right motivation. It really can move mountains. And so ensure you have the hands-on experts and share the insights internally. We share this kind of stuff within the companies, but also, as today, sharing it externally. If you're interested in more information, as Christoph mentioned in the beginning, be happy to address your questions now or also later. But there's also 2 pointers. There's an article in IEEE software on the curriculum program that's freely available through that link. And also we have an upcoming experience report at an international conference on software engineering education and training that's coming up on our industrial experience with the craftsmanship topic. So I hope that was of interest to you, and I hand back to Christoph, and I'll stop sharing so that I can see your faces, hopefully.
Thanks, Francis. And we realize the passion you have with this program, and having worked with you over so many years, and even at the very start of this program, already exchanging experiences. I'm really glad to have such comprehensive overview, and I can definitely recommend that article in IEEE Software, which I also enjoy very much. Maybe first question, just to allow others to think about their questions. We received already some. You can also still vote on the questions. Coming to this topic of technical debt and also this short long-term perspective, what we often see in companies, and I also saw it in my previous company, is that you focus often into the short term because this is just what has to be done now urgently. There's the time pressure, there are the deadlines, etc. How would you, what would you recommend to the audience to convince on that perspective into technical debt, into invest into good architecture, as you just said? What kind of guidance, one or two topics could you pass on?
Well, for one, it helps if one can establish in general a corridor for addressing technical debt. And we have the benefit of being able to do that then across the company. If business line A has like a 5% or so corridor for addressing technical debt, and then that can be useful for business line B convincing their management, let's have a corridor. So we have that's a benefit that we can do that across the company, and so that 5% is fairly typical for being able to address that. But if one has that would be the main thing that I could recommend there. The other thing is to have other even company internal person come in and look at, right? This is this peer review that we've done. So it's not something that can happen super short term, but within 3 months or so, we can have a case where then an internal expert team can come in and have a look and give their neutral opinion. And it's all then internal, right? They're not worried about sharing, and people are already in the general domain. So being able to use this peer network where all of the architects sort of have the same way of thinking about problems, and then having a common, sort of like the Software Engineering Institute's ATAM trade-off analysis method. It's a sort of a version of that we apply. And so having somebody else internally being skilled at giving that view and saying, yes, we really should stop the line and fix this first and then go out, right? And sort of hearing it from a more neutral view than from your own development team maybe helps. And I guess similar, like presumably Vector also does that kind of thing, is also a neutral source for getting that kind of thing. So if you don't believe your own team, do you believe a sort of a neighboring team, or then even a completely external team? Yeah.
Thanks, Francis. Maybe we keep answers a little bit shorter because there are still a couple of questions. Related to the previous one, you mentioned this aspect of benefits in terms of networking, establishing a certain culture. At the end of the day, it comes always back into the bugs, as we say. How do you measure the success of such training or learning, as you said, initiative?
We often have asked for feedback from the managers of the persons, not the persons themselves, but maybe one level removed, and they have often given us feedback that the person that went into the senior software architect program came out totally changed in a positive way and can handle many more different situations. It's hard to then put that into financials, but the same manager said they really notice a significant change and much more mature approach to the topic. Yeah.
Thanks. There's one from Walter Bernhardt, which asks, what education approach would you recommend for organizations that are much smaller than yours? So, I mean, in other words, how can we get started in a smaller scale organization?
Yeah, well, some of this is available in things like in the developer side. The software craft material is there and can be done to some extent in self-learning. There are some, online things available for getting started, but one needs to maybe within your company have a set of persons that have the time from management to drive the topic. Like our software craftsmanship program that we have, not only the training, but we have a program. There are people that basically have the time to then grow the software craftsmanship topic within their organization. And so, explicitly saying this topic is important to us, you have the mandate to go and do that the way you think is right for other developers. And that seems to work for us. Yeah.
And in a way related is a question of Thomas Wunderlich, who asks about references, which could also be helpful to grow such a program. He mentions the ISAQB and the TOGAF. What would be your recommendation? I mean, you may also refer to books. What could be a good anchor point to get started?
Yeah, I think the ISAQB I know quite well is also a well-respected program. I think it's not as broad as ours with the social skills and some of the other aspects, but as far as architecture, it has a good reputation. And then there's other things like in requirements engineering, also the IREB and other activities. I think Germany is particularly active in this space, I have the impression.
And there are two questions related to roles. The one is a bit extreme, that is asking, is it right to assume that the architect can be thought as a project or product manager with a lot of deep technical knowledge? Vice versa is another question which says, how do you keep a relation with the product manager? So I guess it's a useful point now to illustrate how do this role really contrast and enrich each other.
Yeah. Well, we consider it's a triumvirate, so three, that you have the product manager, the project manager, and the architect, and that those are the sort of the three main persons. And like the product manager would be, in an agile sense, the product owner. Yeah. So we see it as three separate roles and responsibilities, but that work aligned together. Yeah.
And I think we have time for one concluding question, which is quite insightful, is specific to medical, but I would even go further than that. And he thanks you for the presentation, and he says he knows people in health industry who are taught already in university or afterwards. And now I quote, if you make an error, somebody will die. I mean, we hear that everywhere in wherever safety critical, you know it, I know it. But that, of course, is not exactly what you typically call a failure culture, because it means people would probably put things below the carpet. How do you deal with these kind of misperceptions, which I can imagine, especially on the managerial level, to push, you're not supposed to make errors. So what's your recommendation here?
I'm not sure if I quite understand the question, but I mean, basically internally, we're improving further how we go about experimenting within the product, right? But the actual product development and how it is checked and validated and so on, that is not negatively impacted. It is, if anything, it's some further additional checks on it, right? But we need to be able to try out certain technical things if something is going to be able to work fast enough and so on. But there's always the sufficient additional checks built into the system inherently. Yeah, and I think and a lot of those kinds of things are very, very important and top priority for us. Yeah.
I think it was a good closing comment. That's also why I spared the question, because in a way it's like what you call this bridge building. I mean, of course, we have to fail early, but we have also detect the failures or the defects, and then we have to repair. We have to build resilience into our systems, and I think that's exactly what is also your message. Francis, I thank you very much. I would briefly close with a few concluding remarks. On the one side, and you should now see back on my presentation, the survey shows a split of about 25-75, so 3 parts, 1 part in terms of the systematic role competencies. I think we learned a lot today about a complete learning program and how this is set up, how this can be established and also moved forward. Where do we go from here? Well, we have a bit more to come. We have next week, same time, the software-defined vehicle, a presentation which comes out of our experts here in Vector patterns. So it's also about architecture, process, technology-related topics. How do you establish software-defined X? Let's call it like this. And we have still one to come, which is about autonomy. And beyond that, we have already the planning for the 25 Vector Forum ongoing. You can register with the QR here, and it's about this emergent connection or bridge, as you also say, continuous IT for critical systems. In other words, how do we connect enterprise and product IT in critical systems? Small reminder on this quiz, which you find the link here, and also can just go there. I think it should also be in the chat. And we'll see each other again on either next week or whenever you visit the recording. Just feel free to send a note. And thanks again to Francis Paulisch of Siemens Healthineers. Francis, you did a very good job to explain this learning environment and also the benefits and some very useful takeaways. Thanks for being available today.
My pleasure.
I wish all of you good success in deploying a good architecture and not just rushing into the fast pace and sacrificing the long-term stability. Thank you very much.